Hey folks, in this video I want to introduce the idea of modular programming. Now this is probably not going to be as fancy as you expect. Somehow this is a way basically to group code in C. So thinking back for one moment, when we use a language like for example Java or C++ as object-oriented, we have kind of out of the box a nice way to group things together. We have this idea of something called class, and I can put multiple methods together, and I can even put my classes in different files. Makes things nicely structured. So that's actually what we kind of want to start doing here. So we're not going to go the object route, but what we're going to go at least is to having multiple files in a single project, because usually that's a better option from the perspective of just being able to find where things are at, or be able to work with them a little bit easier, maybe to compile faster, that type of thing. And so that's what we're going to start taking a look at in this video. So first, what's the problem? The problem is that we can have programs that are maybe very, very large or very complex. They have hundreds of functions. At a certain point, you're not going to want to have just one main.c file that has a million functions in there, because then it'll just be hard to work with. It'll take maybe a long time to scroll around, right? Very basic, right? Maybe it takes a long time to save or whatever. It's going to be a lot of work, right? To deal with a file that's very large, you're just going to have a hard time getting around. So what do? Right? We don't want to put everything in one file. What we want to do is maybe break it into pieces. So ideally what we want to do is basically take a large program that has many functions and group it into different pieces, right? And these pieces should be maybe several functions together. And the idea, right, is that these pieces are maybe easier to deal with than the whole program in one go. So we can group things by several reasons. We can group it basically in terms of like putting things that are conceptual together, right? So maybe I want to have something like a stack or a queue, right? I could put all maybe the functions that relate to that idea together, right? So I could group things by some sort of concept, right? And maybe right if I do that, I can actually start thinking about maybe doing some data abstraction stuff as well, right? If I group things together like that. I can also think about grouping it together, right? Just as a basic way to maybe reuse things. So for example, I mentioned right now a stack or a queue. You can imagine that we could maybe implement a file in C that stores all the functions we need for implementing a stack, right? You have push, pop, something else, whatever you need. And if you wrote that in one file, you can maybe take that file and use it in different projects that all need to use the stack, right? And that would be a very nice thing. Another thing here that would be a reason maybe to break things into little modules is basically this idea of things will actually compile faster, which maybe will sound strange at a glance, but think about it for a moment. If you have a bunch of different files and you're trying to compile a project, the only files you really do need to recompile when you make a change are the ones you change text in. So if I have separate files and some of the files I don't change, I don't actually need to spend time recompiling those to a new binary. Instead, I can just use what I already have. This is actually a very, very nice thing to have, right? So if you can imagine I have a million line project. It'd be nice just to be able to recompile the parts that you changed. So this would be another reason, okay? So we have several different reasons why this would be a good idea. Overall, what we want to do is take our large programs, break it down in these pieces, right, where I have things that are kind of grouped a little bit, and then go from there. So the term we're going to use here basically is module. So a module is basically referring to, in C, it's referring basically to a grouping of functions. Typically, a module has two parts. It has a specification and an implementation. A specification is essentially just a list of the functions that this module contains, right? The bits of functionality it offers to the outside world. This looks a lot like an interface in something like Java. The other thing we could have is implementation. And implementation is basically going to be the actual code that does the work, okay? So that's the actual code, right, that you would write. So there's the two parts here, right? Specification and implementation. These are actually kind of related to maybe some file extensions you've seen, which are over here .h, or over here .c. So .c is what we've been doing so far. That's an implementation. That's me writing real code. .h stands for header, and it's typically used to store a specification for some code that's yet to come. Now, when you create this, right, specification and implementation, your specification is basically going to be a list, right, of things that are available, what the functions are available, maybe the variables that are available, and are available to the outside world, and basically that's going to be what other parts of your program can manipulate. Now, the stuff that's inside of an implementation file, a .c file, that's going to be stuff that's not directly available to the people outside. So there we have kind of this sense of data abstraction going on, that we maybe have the ability to hide how things are implemented specifically. All right, so this is our top level view of modules. Let's talk a little bit more. So one example here where it would be something like a stack. So you can imagine maybe you're writing a program that wants to read in a string from the user, load it into a stack, and basically use it to reverse it and then display the reverse string back out. So just think about that for a second. Right? We have this program. What happens if I maybe want to break it down a little bit? And maybe this isn't the best application of modularity because it's a simple program, but just for sake of example, we'll try using it. So there are maybe three things I can think about doing. I can break it into maybe a piece about user interaction, right? So displaying stuff, reading stuff. I can break it into maybe a stack ADT, right? A stack abstract data type, and then maybe have another file that has console utilities, right? So maybe ways you display or format information to the user. And I have that in there really just for an example to make things a little bit short for me on the slides to come. All right, so imagine I have this program. We want to break into these three pieces. Somehow the idea there, right, is I looked at a program, right, I kind of idea what it did, and we can kind of see, oh, hey, I can break into these three different chunks, right? And for those three different chunks, I can think about creating basically a header file and an implementation file, right? So I'm breaking into different modules, right, and each of those modules has kind of those two parts, right, a .h file and a .c file. Okay. So this is kind of our current plan for what we want to do. You can kind of think of, like, for example, like the stack, right? You're going to have a header and implementation file, and those files, right, for breaking this into pieces, are just going to contain the things that are relevant to stack. So, for example, they'll have a push or a pop function, right? Those are things that are relevant to stack, so that's what they'll contain. Then we have separate files for dealing with the console stuff, right? And maybe those are going to be different helper functions, and those will be in the the files that are for the console utilities, and so on and so forth. Again, we're just separating things apart. Now, as a note here, before we kind of end off this video and start talking about some of the syntax involved, we kind of want to keep some stuff in mind when we actually go to create modules. So don't create too many, I guess is what I want you to do at the end of this page. The idea is that a module should keep related code together. It's not a good idea, right, to create a different module, a different file for every little part of your program, right? You don't want to have one for every method, right? For every struct, right? That stuff can be grouped together, right? We can group together multiple functions, multiple structs into one file if they all make sense together, like all the stuff for a stack. That's okay. Don't make too many files. Your modules are intended basically to structure your program in a way that makes sense, right? That helps the program to understand it. That maybe helps out the compiler in only needing to compile half of it, right? Or part of the program, right? We don't want to make this overly complex by breaking into too many pieces. So we want to try to avoid having too many modules whenever we can. Generally, what you want to do is wait for modules to you want to make modules be a decent size, so maybe like 100 lines of code, and then only when those modules become larger, like 200, 300, when they come substantially larger than what they started as, then maybe that module should be broken down itself, right? But we don't want to break it down too early, right? We want to make it be a decent size right before we start breaking it down. All right. So that's all I got for this video. In the next video, we're going to start talking about some of the syntax for actually doing this work inside of C.